Okay, welcome back, everybody. Something I think I didn't say actually when we like last week, or as I was introducing the course. I have taught this course online before. I'm re-recording the lectures just because I think it's just better. Like I update, and I think it feels more like I'm talking to you because I am. I'm not talking to some classmate a year ago. But one thing I did notice, like I have obviously this table filled in from last year. I am very consistent in my timing. Like say what you want about me as an instructor. I have my good points, my bad points, but man, I am consistent. I feel like this is the same slide I took the break on last year. I don't know what that means. Anyway, let's keep talking about web stuff, shall we? Okay. I was talking about these CSS preprocessors. Again, why did I not edit that little rant out? I should have, but you're getting it. Okay. Another sort of helper, I guess, again, sort of down this theme of like CSS, like resets and normalizers and preprocessors. Another thing that can help with this, in a technical sense, at least, very simple language. Well, the language is simple. The concept of visual design is not. So, well, just like everything else, and we're going to see this over and over again this semester, this sort of, well, hey, everybody has the same problem. Why does everybody have to solve it independently? Why don't we all collaborate on one really good solution? Like having like this the breadcrumb kind of appearance, which is something like, sorry, just in case you didn't grow up with German fairy tales, breadcrumbs are these kind of things where you can use to find your way back. So this kind of thing, this widget that's basically, well, I was here and then I went here and then here, and this is what I'm on right now. That a lot of pages need that. That's totally a reasonable thing to do. Again, it's not reasonable to call them breadcrumbs in a not Western European context, because not everybody knows the Hansel and Gretel story about stupid German children leaving breadcrumbs in the woods and being surprised when they weren't there. Whatever, I don't remember the story. But we're going to solve this the same kind of way that, again, problems are going to get solved with client-side development, server-side development, and it's going to be, well, let's have a whole bunch of these all put together, and we'll call all of those solutions a framework, because we're going to use it a lot. I think probably Bootstrap and Foundation are the best known CSS frameworks, although I, to be honest, might be out of date on that one. They're both sort of collections of, one, a bunch of CSS things that you can use, and typically some JavaScript behavior things that will accompany them well. So like in Bootstrap here, as I've clicked randomly, so things like these containers that have particular sizes that are related to the size of like phone screens and stuff. How do I want things to look? How do I want them to behave as screen size changes? Or I don't know, what does utilities? Right, so helpers for margin and padding, and there's a bunch of form helpers. Like I want my select things to look a little bit just less old-fashioned. So they contain a whole bunch of stuff like that, and that can be really handy. And it's good and bad. And I think, like if you look at the like default Bootstrap appearance here, it looks kind of familiar. And I think it looks even more familiar. Like if you like do a tutorial and you just sort of do the basic, like include Bootstrap on my page tutorial, it looks very familiar because a lot of people have used this. And a lot of pages look like, oh, you use Bootstrap, good for you. That's not a bad thing, but there is, again, it can be a certain uniformity at some point. Don't forget that you can customize. And the reason that like this page doesn't look as much like just everybody's standard like just use Bootstrap, is they've customized it. And so don't forget you can do that, right? Like there's all of these things, like their style sheets are apparently Sass based, so you can start by setting a bunch of variables in the Sass code and then build your own version of Bootstrap that has your customizations. Or you can just override stuff. You can just take the classes that you're using that are provided by Bootstrap and in your own style sheet, modify them a little bit. Like these, whatever these deals are. Oh, this is still Sass code. But yeah, you don't actually need Sass to do these things. You can customize with CSS variables or just with CSS overrides. Just change things in your style sheet to make it look the way you want. Don't forget that part. If you're going to use Bootstrap, I guess my advice is at least change enough defaults that when somebody opens your page, they don't say, "Oh, Bootstrap." But yeah, these things, like these frameworks, are very handy. And again, depending on the context, depending what I was doing, like again, maybe these buttons, this pressing this is dangerous red button. Well, people kind of understand this visual language because it is fairly common. People understand that these things are buttons because they are fairly common. That might be a good thing. And it saves you, do you want to worry about the code for a carousel, which are we going to work? Oh, there we go. This kind of thing, right? Where you can flip through things. No, you don't. You want it to just work, and theirs just works. This kind of thing happens. Oh, do we not have a carousel at this very moment on the SFU front page? Right, because a safety plan has taken part of it. But usually it's like everybody wants their thing on the front page. So if you have a carousel with 4 things, 4 people win instead of just one. If we're kind of honest about how that gets used. Yeah, it's nice to have that thing. Okay. On our sort of tour of just getting web pages out there, which again, I think most of you know most of the basics, but we've talked about these 2 things. And I sort of referred to them as step 1 and step 2, right? So take your content, mark it up with HTML, be as semantic as possible. Don't worry about appearance. Worry about just, here's my content, here's what it means, here's what it's for, here are its semantics. Then CSS, make it look the way you want. And this is like, in like a software engineering course where you're told okay, well, make the requirements and then make the design and then whatever the waterfall methods things are. Okay, so you've taken that course. You know how carefully you follow, right? You wrote the requirements and you made the design and you started implementing it, and then you realized your design wasn't perfect. You went back and you modified your design a little bit, and you went through and you realized, oh wait, this button that obviously should be there was not specified in the requirements. So you go back and kind of add it to the requirements, and you pretend you didn't do that, right? You pretend you did the whole thing from start to finish. Same thing here. Yeah, of course you end up going back to your HTML, and I think I even did it last week when I was playing around with this page, right? You come back here and you realize, well, I don't want to have just code examples. I want my code to be different depending on the language it's written in. Okay, so I need to come back and I need to add some classes there so I can grab a hold of those things with CSS and modify them the way I need to. That's perfectly reasonable and normal. And then this third component, that is, how does it behave? So this is things like, well, what happens when the user clicks this or does that or whatever? Now, of course, there's some behavior things that are sort of free and, oops. We know what's going to happen when the user clicks on this, right? They're going to go to this URL. Okay, so I guess, we can argue that that's behavior, but not quite what I'm talking about here. Like the behavior, what happens, pardon me, when the user clicks on that. Where did my slides go? This is like your modification of the behavior as a developer. I'm gonna not talk about JavaScript much right now. Again, some of you will have dealt with it before. I guess the short intro is there's a script element. You can say, here's a file with some JavaScript in it. It's the one that actually works in web browsers. I guess the other way to get logic that runs in a web browser, well, I guess, okay, 1, write JavaScript. 2, create JavaScript with a compiler or transpiler, I guess. So things like Dart, TypeScript, CoffeeScript are designed in such a way that you can write the language you want, one of these, and then instead of a compiler producing machine code or Java bytecode or .NET CLR bytecode or something, have it produce JavaScript code. Send that to the browser. It's a little weird. It's maybe not what I understand the word compiler to mean, or at least it's not what I thought the word compiler meant, but it'll work. The other thing that you can do in a modern browser is WebAssembly, WASM, which is in the way that like Java bytecode or CLR bytecode is a low-level thing. It's a low-level thing you can send to the web browser and compile some language into and then send to the browser. But one way or another, we need code that the web browser can actually run and actually produce some behavior like on the user's like in the user's window on our behalf. So again, JavaScript or WebAssembly code. Maybe I should have both in that sentence. I think there's this weird, I don't know, like there's some superstitions, I think, among people who are JavaScript first programmers. Don't forget that JavaScript is just a programming language. Like you have variables, you can write loops, you create functions, like all those normal concepts that you learned in like Compute 120 or whatever, they apply to JavaScript. It is just a programming language. You can do calculations and stuff. And of course, you can have more beautiful or less beautiful code. You try to make more beautiful code. But we send this logic to the web browser, and then we can modify the page. So in fact, like, as I'm looking at this web page right now with these slides on it, there's some behavior here that says if I press the left arrow button, it like moves some stuff and changes what's on the display. So that behavior is done with some JavaScript code. So that's the manipulate the page. The other thing that can happen is JavaScript code can make a server request. It can go back to the server and say, please give me this URL. And the server comes back with whatever, some HTML or some, well, bytes, frankly. Whatever those bytes are is between the logic on either side of that request. So all of a sudden we have a way to sort of contact the server and do like programmatic things. I want this, I don't want HTML content. I want something machine readable, something like XML or JSON content that I can parse into a data structure and then iterate over the data structure and add all of those bits and pieces to the web page. And of course, that opens up a huge collection of things that can be done client side, which is where, like if we sort of look forward towards the technology evaluation, so the server-side frameworks are running on the web server. We'll come back to that in just a second. The client-side frameworks are JavaScript or possibly something that compiles to WASM, but I think they're all JavaScript, that are ways to run, like, again, frameworks to help you, I guess, more easily have logic that sits on the client side in the web browser and contacts the server and updates the page in some way that is pleasing to you as a developer, I suppose. So I am definitely going to say far, far too little about JavaScript now. And frankly, I'm going to say far too little about JavaScript in this course in general. For a couple of reasons. One of them is I like the server side better, just my preference as a developer. But really, I think the server side is unavoidable. The client side is nice. The server side is unavoidable. If you're going to store data, do security checks, those kinds of things, they have to be done client side. or so they can't be done client side. They have to be done server side. So I'm going to come back to client side really in a long time. Some of you will have taken the special topics course. I guess it would have been offered as 218 with Bobby Chan. Hopefully that is a good complement to this material. If not, well, learning some more client side development wouldn't hurt. Probably be good for all of us. But for now, I'm going to continue on the theme that I have going on here, which is, how does the web work? How do these pieces fit together? How can we as developers make web things that do what we want? So those first pieces were get content to the user, make the content look the way we want, a little footnote that there's some stuff about behavior that we can do, and we'll come back to later. But how do we get these things to the user is the next question. So if we're talking about the web, the answer is with HTTP. So there's HTTP 1, 2, and 3. There are these different versions with Speedy sort of sitting in the middle. I'm just gonna say HTTP and kind of refer to all of them here for at least the moment. I guess HTTP, standing for Hypertext Transfer Protocol, was more meaningful when the acronym was originally created. I guess transfer protocol, that much makes sense, right? We're going to transfer HTML and CSS and images and JavaScript and whatever. Hypertext is by now a very old-fashioned word that means something where there's text that you can click on. So here's some hypertext, and it's because there's text that I can click on and something happens. So when that was a new concept, it was called hypertext, and the web was an example of a hypertext system. Now, nobody has to be told what links are, and nobody uses the word hypertext, but here it is, kind of hanging out for historical reasons. So that's how it got there. So again, I think I said this last week, but effectively, something is on the web means I can make an HTTP request for it. Those are synonymous. It's just the less technical and more technical way to describe that. So again, the web and HTTP are fundamentally inseparable. They're the same. HTTP is nicely simple, and I guess maybe I'm referring specifically to HTTP 1 here. Things have gotten a little more complex over the years, but not hugely conceptually different. And something else I think I said last week was, I'm not concerned at some fundamental level about HTTP. I'm not a protocol geek. I don't really need to know exactly what bytes get sent over the wire. What I want to do is make better web things. And if you don't know how HTTP works, if you don't have these ideas about the fundamental underlying protocol that we're all using, you can't use it effectively to make things work properly. And I definitely see this among less experienced developers and in projects where that knowledge wasn't there in the design. So let's start with some basics. And again, now I'm definitely referring to HTTP 1 here, where again, conceptually, not really very different, but I'm going to request this URL, this super not very exciting URL. So in fact, that thing I just did, right? I typed the URL, I pressed enter, or I found a link to that URL and I clicked it. So that's the thing that we're talking about here, this operation. So the user agent, web browser, as I just did the demo, but it could also be something like, where's my command line? I could do wget for that URL. So that is also a user agent, the wget command or the curl command. All of those are user agents that can do this. So make a TCP connection. If you don't know what TCP is, I don't know, go take 371, but connect to is perfectly, if you want to just read this as, connect to the server on port 80, that's fine by me. So because I've said HTTP here and not HTTPS, that connection happens on port 80. And I guess we don't have strict transport security on that domain, so it was honored. I guess I'll compare and contrast another one later. But this is what my web browser just did. And this is like, these are literal, like this character turned into 8 bytes as an ASCII character. Like literally these are the bytes that were sent over the wire, like this new line, this followed by a new line, and then one extra new line at the end that's really hard to draw on the screen. So this is a kind of request that got made, right? So I connect to the server, right? So the server's in the URL. I'll connect to that on port 80 because of this bit. And I will request this path, which is this part of the URL. Yeah, so I want that path. Again, I'm talking about HTTP 1 here. There's a host header that's required, and then some other stuff. Like I don't, and I guess I can, again, I can ask my developer tools here. If I reload the page, it turns out, again, I don't know if I can keep everything reasonably on screen at a reasonable font size, but please, can you just show me the friggin' request? Okay, let's do that. No, oh, it's here. Okay. Yeah, okay, so I'll try to keep these two around. Let's see if I can do that. All right. So just as an example here for the slides, this is the kind of request that gets made. And in fact, I can do this myself, right? I can. So telnet is effectively, this command is effectively connect with TCP. So make a TCP connection to this thing on port 80. And then literally type this, copy paste it, I guess, followed by a blank line. And this, so like, you know, up to this point is what I typed. I typed that blank line, and that was a valid HTTP request. The server responded. Let's have a look at this, and maybe let's sorry, I'm going to copy and paste that again, just so I can have all the things there. And by the way, I'm going to ask you to do something like this in exercise, I believe it's 3. This is probably the way you want to do it. Like create the thing in a text editor and then copy and paste. Otherwise, the thing is going to time out. Like there is some amount of time the server is willing to wait here for me to get my request made, and it's not long enough for you to type the thing by hand. So yeah, copy and paste that in there. But the pieces that are going on here, this very first line is different. Like it's different than the others and a little bit special. It's the request line. So it's the verb, the request method. I'll talk more about request methods in a little bit, or next week, depending on the order of slides here. And then the path. So again, I already know I've connected to www.sfu.ca. And then this is the URL that follows that, the path component of the URL. If there had been a query string here, so that's the thing after a question mark, that would also be here in the request. And then which HTTP version am I speaking? So again, like 0.9, 1.0, and 1.1 all follow basically this format that I'm talking about. And then all of the other lines in the request here, at least as I'm showing it, are HTTP headers. So these are all like, you know, effectively key value pairs. So it's feel like the thing that I'm talking about followed by it's the value that I'm giving it. The host header is required in HTTP 1.1 and later, but is effectively given by everybody all the time in every client. The other ones are optional, but this is fairly reasonably common, if maybe a little minimal. I'll come back to the accept headers later on. Oh, I said connection keep alive there. And so let's try that again, actually. So connection keep alive is, you'll notice that like it took a second there. Not very long, actually. I'm surprised how little time, but that was the server waited, and I had a moment when I could have made another request. So I don't have to sort of create a new connection if I'm going to download an image or a style sheet to go with this page. Like I said, the host header is required. And this is because like it really feels like it's redundant, right? Like if I connect to this server, why should I have to tell the server what its name is? And the reason is there's potentially a lot of websites hosted by that one IP address. And I'm not sure I can think of one. I'm not sure I know enough about SFU right off the top of my head, but I'm willing to bet that I could find some other web server around the university that has the same IP address as www.sfu.ca. Like this same machine or collection of machines or load balancer or whatever it is can serve more than just this website. I bet if you find some other, something.sfu.ca website, there's a moderate chance it's going to have that same IP address. So in fact, we do have to tell this computer what its name is because there's more than one choice possibly. So that's why that thing is there, and it's why it's required. And then there's other information about the request that is being made, like how are we making this request? Who is making the request? What kind of response do we want? Again, let's compare. Again, I can never. Right. So yeah, I'm always kind of annoyed. Like all the information is here, and I can't change the font size. If you can't read it, there's nothing I can do about it, I don't think. Yeah, but so there was somewhere here. There's the fact that it was a get. Right. So this request line is up here, and then all the request headers are down here for whatever reason. They're just separated in the display. Crap. Well, now that I've recorded that cookie, I guess I'm going to have to log out of all my SFU things before this lecture goes live. I will do that. Crap. Anyway, but this is the actual request that got made. Pretty much the same information, ever so slightly more verbose in the real example. Oh, right. I guess I wasn't done the story there. So I have the request line, one or more headers, and then this blank line that says, we're done with this part of the request now. So for a GET request, that marks the end. If it's a POST request, there can be a POST or a PUT or a couple others. There can be something called the message body down there that is the actual contents that are being sent from the client to the server. But for a GET request, so as long as this word is GET, that second new line is the end of the request. So, and again, what happened back there was when I did this manually, like as soon as I pressed enter this second time, or I pasted that second new line character, the server started sending with this part of the response. And I guess you can see, like, this is HTML, right? Like there's no secrets here. This is just the actual contents of that file, or the actual contents of that resource that was sent. If there's a style sheet to go with it, then I would have gotten, or like if I'd requested a style sheet, then I would have gotten CSS contents here. Or if I'd requested a JPEG image, I would have gotten the JPEG contents there. Like whatever those are, I interpret those bytes as they are. Oh, sorry, I said that wrong. The response started here. I'll come back to the details of the response, but the response body, the stuff after this highlighted bit, are the actual contents. Okay, those request methods. Again, I feel like I'm spending a lot of time on like this one line and this one word because it's kind of important. So again, the request method is that the word get there. And that's like by far the most common, right? Like if you click a link, if you type a URL, it's going to be a GET request. For the moment, at least, let's say it's the only way you're going to get anything else is with an HTML form. Of course, if you're making a request with code, you can do whatever you want in that code. But for now, at least, let's just say, I don't know. So yeah, so when I'm making a form, I'm going to say something like this. So this is like, it's a search box, or, enter your information and submit it kind of thing, where I have an input. So point being, I'm explicitly giving the method here. I can say get, I can say post in that position. The difference is, there's like a technical difference and there's a semantic difference. If I make a GET request, and maybe I should actually do this. I guess I'll call it that, the text input. That should be pretty obvious and we should be able to see it. And then I need a submit that I can actually click to submit the thing. Let's try that. That's this one, right? Yeah, okay. So this is my thing. I click submit. Oh, I had, right, sorry, I wanted method equals get there. Okay. So forgiving the fact that this doesn't actually exist, the actual contents got there. So that's the URL that ended up being there. So I went to this the relative URL, and all the stuff on the form got sort of encoded like that as a query string in the request URL, the requested URL. That's fine. If I had changed that to a post request, which is actually what I did originally when I first clicked that button, you don't see it. Like it's much harder to see it in a demo. I guess it's not in the URL. Like that stuff that I typed is not there. It turns out it was in the, again, I don't know if I'm going to be able to see it here. No, because it's not actually over the network, so I can't see it in the network tab. But it's encoded into the request body. So that is like that stuff that I had typed. I would have ended up with a request like this. Give or take, my memory of what I just typed, I would have ended up with a request something like that. So the blank line, and then I would have had the message body, and I guess I have to have the content size header, that is however many bytes are down there, something like that. So form contents are in the request body, or they're in the URL as a query string, though that's like in some sense the technical choice I'm making here. Which one do I want? In a practical sense, like if what I just typed was my password, well, I don't want that to be up here visible on screen so somebody standing behind me can see it. It also means that, like, for this URL, if I bookmark this URL, the bookmark only saves the URL itself, not whatever was in the request message body. So I can't effectively bookmark that page because there's extra information that's not stored as part of the bookmark, or if I copy and paste the URL or whatever else. But there's this semantic difference that, again, this is something that way too many web developers apparently don't know or don't remember when it comes time to make that choice. GET requests should be safe. And that's safe in the sense that they don't have side effects. Like, and I guess at this point, I have to maybe decide what this is all about. Like, what is this form I'm creating? If it's a search form, like if it's just, I want to search for this and I want to find it, well, there's not really any side effect there. Like maybe I'm writing a line to a log file or something, but I'm not like having any significant effect on the world. This should be a GET request. It's safe. And what that means is I can reload this page. I can reload this page all day. There's no side effect to hitting that URL again or making that request again. But if this was a different form of like, change your screen name or something, you know, something where there is a side effect, then I don't want that to be a GET request because there's a side effect. So if I'm going to have a form like this, I really want to put post there. And again, it's a subtle difference, but so many people just don't do it right. They either accept a GET because it's the default, or they just use post everywhere, and then making it so you can't use bookmarks. So something like GoSFU is a good example of the just, oh, let's just use post everywhere because whatever toolkit or like whatever piece of software it has been written in maybe defaults to that or whatever. Like you just can't bookmark anything in GoSFU, and that's really annoying. Like it's really annoying that I can't give you a link by email that's like, oh, go here if you want to. I don't know what students do in GoSFU, so maybe I never need to do it, but I can't, and the advisors can't. Like the advisors can't send you a link that's like, oh, here's how you drop the course. They have to say, go here and click this and click this and click that, because everything is a post, and that's really annoying. Another reason is software makes this assumption. Like if it's a GET request, there's this assumption that requesting that URL is safe and isn't going to cause any like action on the user's behalf. So this, I mean, you can read the story yourself, but the short version is this Google Web Accelerator, a short-lived product, as all Google products are, sort of pre-fetched pages. And web browsers will do this, right? Like it's totally reasonable. Like if I was writing a web browser, if I want this web browser to feel really fast, faster than that other web browser, if I move my mouse over this link, if it was going to be a GET request, maybe I should prefetch it. Like if that way, like if the user comes down here and they click, maybe I'm a half second faster than every other web browser because I say, well, okay, it doesn't matter. It's just a GET request. I can start the request before the user actually clicks to the link. That's a totally legal thing for a web browser to do. And that's the Google Web Accelerator was like prefetching a whole lot of stuff. So if a developer doesn't know this, if they have, and I think the example was like a link that said delete was a GET request. So Google Web Accelerator did what it was supposed to do. It prefetched a whole lot of links that the user might click on and deleted everything that user could delete on that page. That's probably why people didn't use Google Web Accelerator, because so many developers just get it wrong that it would have been an incredibly dangerous thing. The other reason that like people don't tend to like post requests is if I get to a thing that is a post request, I guess like again didn't actually load. Where can I see a post request? Probably not easily, but this, like if you click reload, or, hit Control R or whatever, web browsers know this stuff. Something's going to be changed here, right? If this link was like buy a thing, right? If you're on Amazon, you click the thing and it buy the one-click buy or whatever it's called, buy the thing. If you're sitting looking at that response to the post request, if you reload that page, you might buy another thing. The web browser assumes that might be dangerous. So if you reload that page, the browser says, hey, are you sure? Do you really want to do that? And that's in some ways annoying user interface to have that thing. So the post redirect get pattern that a lot of server-side frameworks will push you towards. And I think maybe this. So like the thing that I've just described is fill out the form, click submit, make a post request, get a response back, and then you're looking at the next web page. If you hit Control R, then you resend that request and you, again, make another order or add another course or whatever side effect you're imagining. That's not probably what users want, and you probably, just as a developer, want to protect them from that as much as possible. The post redirect get pattern is when the user does a thing, click submit, you have the side effect, and then instead of sending back a web page, you send back a redirect and you send them off to the page that is, okay, your order is complete, but that page is a get request, so then they can refresh it all they want. Yeah. Your order was still placed. Yes, your order was still placed. Yes, the course has been added, or whatever the side effect is. And you sort of immediately get them away from that danger area of that post page, page that was requested by post, I guess. So yeah, you will see that. And it's kind of a nice way to let you, the developer, use a post request at the right time, but still let the user reload pages and bookmark pages without danger. There's some other HTTP request methods that we will come back to when I talk about REST. Sorry, well, later. Okay. I think I'm done talking about the request finally. And so again, we send some request like a couple undos back this. So I'm going to stay with a GET request as my example here. Can I get syntax highlighting? No, too much to hope for. Yeah, too much. Yeah, send a request like this, and then I get a response. And again, we saw one back here. I made a request, and then I got a response. So this is the one that actually came back in the example I was working on. Here's the shorter version that I've included on the slides. So again, this is the first line is special, and then there's some headers, and then there's a blank line. So that much of the story is going to stay the same. There's something, this is the response line, and then some headers, and then again, the actual stuff. Sorry, status line. The first line of the response is the status line. Sorry, that's the English sentence I meant to say there. So it's going to look something like that. It looks exactly the same, I guess, in the example over here. Although I guess I spelled OK differently, but otherwise the same. So again, there's the protocol that we're responding with, the status code, which is the like machine readable version of what kind of response is coming back. Was it successful? Like, is this a successful or failure kind of thing that happened? I'll talk more about those in a bit. And then the reason phrase, this is a complete waste of bytes. So this thing is just the machine readable version of the human readable version of this machine readable number. So I got a 200 OK on that. Of course, you will no doubt know about things like, so if I make a request like that for a page that I'm reasonably sure doesn't exist, sorry, copy. I get, okay, a lot more bytes, but somewhere back here was this. So that's the status line for that response. So same basic shape, the protocol, and then the status code, and then the, again, human readable version of that status code. It's called a reason phrase, apparently. This is telling us, again, what actually happened there. What kind of response are we getting? And then, again, I don't think any of these are required. So 0 or more of these response headers, same kind of thing, like key : value pairs, including like what type of content was it. So back here in this request that actually worked, yeah, so I got the thing, and then those, what are they, 8, 9 headers. I got, again, the server identified itself. I got a last modified on that file. I got told that it's HTML content. Like it's HTML. It's not a style sheet. It's not a JPEG image or whatever else. The browser is sort of prepared for what's about to happen. So after this blank line is the message body. There's 207 bytes of it that are going to be there. So the browser's told that just so it knows. Yeah, this thing is the internet media type. MIME type is a slightly old-fashioned term for it. But again, it's what kind of content is it? I guess in my example, I have this parameter on there. Parameter? I think it's called anyway, this indication of how my characters have been turned into bytes. I will come back. I will talk more about character sets than you're prepared for later on into next week, I guess. But yeah, that can be specified there. It's not from the SFU web server at the moment with this, like whatever is going on with this specific example, and wherever I put that file and however I configured that directory. So just like before, we have a blank line sort of indicating the end of these headers. But then because it's a 200 OK response, what follows after that blank line is contents, the actual like resource contents. Here's the HTML, or here is the CSS, or whatever else. Yeah, maybe this aside, I kind of like, so if you've ever sent an email, you have sent an email, you know how email, so the standard for how email works from 1982, this is actually what defines that conversation format that I just described. This sort of, there's a line that's special. There are headers that are like thing, space, value, and then there's a blank line, and then a message body comes from email. Like it's borrowed straight out of email. And it's, I guess, why there's things like, why is the page contents called message body? Because it was a message when we were describing email, when they were describing email, when this thing was originally described. It's remarkable to me how resilient that has been. Like, and that persisted all the way through HTTP 1, changes in HTTP 2. I guess, right, I didn't come back here on that response. Okay, so again, in the developer tools here, again, I have the thing, my request headers were this. The response headers that came back were, well, I guess the response line that came back was a 200 OK. And then the headers that were after it are these things. And then the actual message body was this. Again, it's broken up across these tabs, but it is what it is. It's all there somewhere. Well, I guess I shouldn't be surprised. This is pretty much what I saw on the screen, because it's pretty much the same request made either way, just by a web browser or by me typing in a telnet window, or for that matter, if I use something like curl as a client. So curl-i is like include the whole conversation. So it's include all of this stuff. The default behavior for curl is to show just the contents. So yeah, if curl makes the request, same thing. Or if I make the request at telnet, or if the web browser makes the request and I have a look in the developer tools, well, of course I get the same response either way. It's just a question of presentation, I guess, after that. So again, like I said, I'm not super concerned with exactly, like, I don't care about the bytes over the wire, but the reason I'm talking about it is things like this. Things like later on, I can say things like, okay, there's this header, strict transport security. It's a response header. So it comes back server to the client. And what this says is everything in this site do HTTPS. So HTTPS is HTTP, as I've been talking about, plus encryption. So this was not encrypted, right? If somebody from like I don't know, SFU network services or TELUS or whoever is in between us on the network wanted to see what web page I was requesting, they could have. Those bytes were literally transferred over the wire as you saw them. If it was HTTPS, and I guess like I can't, the request would have gone to port 443. I cannot type encrypted HTTP by hand. I'm sorry, that is not within my skill set. But this is an indication to the web browser or whatever other user agent we're talking about that if you ever see an HTTP:// URL for this domain within the next 1,000, I think, seconds. Yeah, seconds. Just put the S in there. Everything is HTTPS, just HTTPS, everything on this domain. Don't send requests or get responses unencrypted. So, okay, now that you know what a response header is, I can tell that story. So this is why I'm talking about HTTPS. So we can talk about some of these tricks that HTTP can do for us that, again, many developers just don't know about or forget about. So a nice little intro there to some of those headers that can, again, go in one direction or the other. I'll talk about some of them. So, like I said, I've been talking about HTTP 1 all the way through here just because HTTP 1 is text-based. I can type it. Like I can just type an HTTP response and you can see it, and it happens in this very, very human readable way. In HTTP 2, all the concepts are the same. So, request method, request header, message body, or status code or response, like all of those concepts are exactly the same. They're just expressed in a less human readable way, more like compact machine readable binary based thing. So yeah, okay, it's less bytes to transfer. It's more efficient for the web browser to encode and decode that information. Totally, like in a technical sense, better, but just not as human readable. But conceptually, all the things are the same. And the same, HTTP 3 does change things in a little bit notable way. Streams are a little more first class, but I'm going to say, like, again, conceptually, no change. Asterisks, some change. It is delightful to me, like at least as long as I put a 2 here and I don't talk about HTTP 3 or Speedy, there's just so little change in between the hey, let's have this thing where we can share physics papers with researchers at other universities and, let's have global e-commerce run on it. Just delightfully well-designed protocol. Again, conceptually, almost no changes, at least up to HTTP 2. And so as I say that, HTTP 3 is a really radical change to the underlying protocol. As a developer, I think this is still true, even with HTTP 3. You don't have to worry. Like, as a developer, you maybe need to know something like caching exists, so you maybe care about a cache control header. Like I said, I don't care if that's expressed in characters or some crazy binary format, whatever. Whatever framework, whatever web server will take care of that for you. You have to know how to talk to it, how to make the right request, send the right response. But conceptually, I'm not worried about the difference, at least not at this point. Okay, very briefly, I guess the status codes. I'll talk for a couple more minutes. I don't want to spend too long here tonight, whatever time of day it is as you're watching this. But the status codes that come back. So this is the HTTP 1.1, I guess, definition of these status codes. Again, conceptually, not really changing. So this is where you see something like, okay, 200 OK exists, and if it was a GET request, the requested resource is being sent in the response, right? So I want this, and then the server is going to send it. It's going to be the message body. So that's why, you know, we all collectively know this fact. It's this sentence. So all of those are there, and then I guess the server has this decision to make, right? So the web server, like when I was making these requests, somehow decided that after this request got sent, it was going to send a 200 OK. And after this request got sent, of course, it long story short, in this case, didn't find a file named test2.html, so it sent this. This Wikipedia flowchart that, like, maybe you're a more visual learner than I am. This strikes me as this is the work of a crazy person. I do not understand how you would possibly think this is a way to understand it. But if you do, great. This is like, what's a web server to do? Okay, I had a request come in. What do? We you know what? We've just been turned off. Send a 503 service unavailable. All right, and then we follow this flowchart through here, and if we follow it through in the right way, not this like somewhere through here, there's going to be a 200 OK. That is actually send, we found the thing, or we know how to generate the thing, and we can actually send it to the user. Maybe it's this one. How did we get here? So the resource was created? No. Okay, right. So if we're creating something because we're doing some kind of get, then we might end up we had to create a new thing, so a 201 created. Oh, but no, in this case, we're just finding the thing. So I'm trying to figure out what part of this flowchart led us to 200 OK here. So it wasn't a newly created thing. It already existed. Does it have a URI? I guess so. Like, how else did we get here? But okay, 200 OK. Again, if you want to have a good solid look at that flowchart, then great, you should do that. I'm not going to. It causes me anxiety. So the status codes are broken up into, like, I don't know, categories, families. The 100s are the informational ones. Let's see, like continue. So this is like if the client, web browser, or whatever is sending like a really big request, partway through the server can come back and say, oh yeah, keep going, I'm here, don't worry. Or this is like, I want to switch from HTTP 1 to 2. So the server can, the client can say, why don't we conduct this discussion in the newer protocol, and the server can come back and say, okay, well, I'm going to send you a response then with HTTP 2. Be prepared, because you told me that was okay. Otherwise, otherwise there's not much going on there in the 100s. The 200s are the, broadly speaking, success category. The 200 OK that we all sort of think of as the maximal amount of success that can kind of come back from a request. I requested this URL. Yes, here it is. And again, somewhere in here, it was a GET request, so we're going to send the contents. Or if we made a POST request, a 200 OK would be, well, okay, entity describing the effect, which is possibly a web page. Like maybe it was, yeah, okay, you have successfully bought the thing, is the way a server could respond to a POST request. It's an option. There's let's see, what else we got. So we had 201 created. A lot of these are for, like if the interaction we're having with the web server is more API-like, where we're doing things like, okay, create this object, retrieve the object, delete the object kind of operations, then, okay, well, yes, I have created it. This is the version of success for that kind of operation. So some long-running job, like I have started your task, I will have a result for you soon, that kind of thing. Content, partial content. So this is, again, if I don't talk about REST APIs here, this is sort of still on the table. But partial content might be something like, okay, is something like, this is a big file or big piece of content. I only want the first 1,000,000 bytes. And then the server responds, okay, here's the partial content that you requested. And then maybe later I say, okay, I would like bytes 1,000,001 to 2,000,000 as a separate request, so I can request a large resource in multiple chunks. Or maybe I requested the whole thing and then it failed partway through. I would like to pick up from the last byte I actually received. So you can do that kind of thing. And if you have some obviously completely legal files to download, a lot of file downloading tools can do this. I don't know if web browsers do or not. Like maybe they pick up a download partway through. Okay, looking at the time here, I think that's a good, like, I'm not going to usually push right up on the full 3 hours in these lectures. I don't think it's worth it. I have enough time to say what I want to say. So I think I'm going to stop there. That's probably a reasonable spot. And I'll pick up here, talk about some more status codes next week. Finish as what is exercise 1? There's an exercise due on Friday. Do that. Form your groups. Go to the discussion forum if you need to talk about groups and things. Otherwise, I'll see you next week. Bye, everybody.